Hello and welcome to week 9. We're going to do another CUX circuit, so I'm going to open CUX first thing. And this week we will do a digital circuit. So I clicked on it and I'm waiting. And waiting and waiting. Oh, there, I clicked on it. Now I'm waiting. Alright, it's open. Going to a new project. And I'm going to name the project egr125week9, although it's really week 9. I'd lost a week in there somewhere. Schematics, an untitled schematic. I want to go to the Components tab, and the digital circuit has its own tab labeled under Digital Components. So I'm going to click there, and I'm going to start building a circuit. First thing I'm going to do is scroll all the way to the bottom and drag over a digital simulation. Digital simulations can either be truth tables or they can be time maps. By default it comes up truth table, and that's what we happen to want for today. Next thing I'm going to do is I'm going to go up and I'm going to show you truth table or time list. And so I can display either. For today's purposes, we want the truth table. Time list shows you what it's doing, and it's more for applications where something is changing in time. Okay, so I've got my truth table set. For when I do simulate, go all the way back at the top, and I'm going to pull in some parts for a circuit that I kind of had in mind. It's going to be a 3-input circuit, but I'm going to put a few gates in here, a few different types, in order to create a little variety. The first one was an inverter gate, and then I'm going to choose an import AND. The AND means I can change. By default it's a 2-input AND, but I can make it a 3, 4, 5, 6, whatever I want to. We're just going to use the 2s, and I'm going to pull 2 of them in. And then I'm going to go to the import OR. Once I find it, there it is, and I'm going to drag it over as well. And I'm positioning my gates basically in terms of stages. So there we go. Alrighty. Now, I have a circuit in mind. Nothing special. Just want to show you how to do it. It's all about getting used to the software. In order to simulate, I got to have some digital sources, at least one. So I'm going to pull some digital sources in there. I'll place one there. Then I'm going to pull another one in. I'm going to place it there. And finally a third one. There you are. Escape gets me back to my arrow key. And so now it's a matter of connecting the dots or drawing lines. My middle gate, I guess my top gate's going to go into that AND. I lined it up accordingly. The middle gate's going to go into the inverter. And the bottom gate's going to go over and up into this bottom one here. And I'm going to connect that one to the other AND. And then I'm going to break off of this one and go up, and it will be the second input to my AND gate. Now I got my ANDs all wired up. My 2 ANDs coming out will go into my OR gate. And I'm trying to be a little bit neat with the lines. Nice, straight. Always make your turns at the same point, etc., etc. Now I'm going to go up and label some nodes. I'm going to call this input A. Anytime you've got a digital circuit and you've got inputs, usually they start with the alphabet A, B, C, etc. So I'm doing A, B, and C. And when I go through an inverter, typically it becomes not B, so I'm going to label it not B. So that point's not B, and then my output is Y, or out, O-U-T. I can label anywhere in that circuit I want to. I just chose these for the time being. Okay. Still got my A cursor there. And I hit escape, go back to the arrow. Now what I've got to do is I've got to set up my signals coming in, my signal sources, such that I simulate all the different binary states. As you see, this one starts out low and then is 1 nanosecond low, 1 nanosecond high, and then it will just repeat 1 nanosecond low, 1 nanosecond high. Nanoseconds is pretty small. I normally change these to milliseconds. And if I click on times, it will allow me to get up there where I can change it. So I'm just changing the M to an N. There you go. Going to apply it, and then OK it. Then I need to go up and do the second one. But I want to show you what I'm doing first. I'm going to go to this week's worksheet that I was working on, the rough draft, if you will. I'm going to open a spreadsheet. Handy use of a spreadsheet anytime you want to do some numbers or something. It's just awesome. So there's input A. There's input B. And there's input C. I'm going to center everything in the column to make it a little more visually appealing. And then I'm going to count in binary. So 0, 0, 0 would be the first possibility if you have 3 inputs. Then a 0, 0, 1. Then a 0, 1, 0. Followed by a 0, 1, 1. And I'm highlighting that is what a 3 would look like in binary. Now I'm going on to the 4, which is 1, 0, 0. The 5 would be 1, 0, 1. The 6 would be 1, 1, 0. And the 7 would be 1, 1, 1. Okay, each of these columns is changes every time. The C column is worth 1. The B column is worth 2. And the A column is worth 4. So I'm doubling as I go up. And so to get the numbers, all I do is add up. So I've got 0, 4, 0, 2s, and 0, 1s. So that is a 0. I have 1, 1, so that's a 1. The next row down I have 1, 2, that's a 2. The next row down I have 1, 1, and 1, 2, which add together and give me my 3. The next column down I have 1, 4. Next column down you see it's a 4 plus a 1, which is a 5. The next column down is a 4 plus a 2, which is a 6. And finally the last row, I keep saying column, is a 1 plus a 1 plus a 1, which is a 7. So that is 0 to 8 counted in binary. This gives me every possible input condition going into my digital gates. There, I've got it all covered. In the digital class, you'll learn about the gates. You'll learn about doing this manually. For now, we're trying to get used to the software, and I wanted to give you a little bit of background as to why I'm going to set up my digital sources in the manner I do. So let's go back to CUX. I set the C up to be 1 millisecond on, 1 millisecond off, starting at 0. And so now I'm going to go up to the middle one. And I'm going to make it have a 2 millisecond cycle. So the first one was 1 millisecond, the second one is 2 milliseconds. 2 milliseconds. 2 milliseconds on, 2 milliseconds off. Okay. You see there I added a space between the 2 and the milliseconds. I'm going to go up to the A, and I'm going to make it have a 4 millisecond cycle. So it will be low for 4 milliseconds, and then it will be high for 4 milliseconds. Now, however long I run the simulation, it'll just repeat. Okay, I notice that I have a space in one but not the other. Hit OK. I'll go back and take the spaces out. If something is odd, you've got to pay particular attention to what you type in, because a space here or there, just like in computer programming, will kill you. So now I'm checking this one, make sure there's no spaces, and we should be okay. Alright, I got my digital circuit set up. I've got it set up to where over time, particularly 8 milliseconds, I will have every possible input condition going into the gates, either a 1 or a 0. By default, the digital signals have a 1 as a high and a 0 as a low. All the gates are set up like that. You can change it. I haven't found the need to. After all, we're just looking at logic. So I'm going to save it. And I'm going to call it something creative. Again, it's week 9, and I labeled it week 8. So I'm going to call it week 8. Okay, so now I've done that, and now I'm going to simulate. And I'm going to wait and wait and wait. There we go. My display window has opened. And now I've got to look for the truth table to put in there. And then figure out what I want in the truth table. I want A, B, C, and probably the output. You could put not B in there if you wanted to. Doesn't matter. Okay, I got to exit out because it's trying to give me a second window. So I either hit the escape key or go up and hit the arrow. And then notice the little red arrow up there on top of the box. That means there's more to it than is shown. So if I click on it and then click and drag, I can see my whole truth table. It's not exactly the way we laid it out on the spreadsheet. It's backwards because my first column here is, or the A column varies every time. The C column is off for 4 milliseconds, and then it's on for 4 milliseconds. The truth table I get out, though, however, is, any way you simulate it, you're going to get the same logic out. And this particular circuit will be on exactly half the time based on the input conditions. Well, not half the time. It'll be on exactly for half of the available input conditions. That's a better way to say it, because this is not a time circuit. So I'm looking at this and thinking, I got the right truth table. Don't really care for the layout. It's sort of backwards. Interestingly, the stuff in the far left column is what I put in the spreadsheet table. So I'm going to resize my box to make it look a little better. And I'm seeing that these don't match up. So I'm going to go in and switch A and C. And what I found is if you double click in the graph, it goes away. If you double click on something. And then I'm going to reorder them. C, B, A, then the output, and then I can apply. Okay. Now my inputs, C, B, and A, match the column to the far left, and my outputs match. Okay, it says I had a warning in the last simulation, pressing F5, and it says there's some kind of duplicate value. So at a time, so what I found is when these circuits start repeating, you sometimes get that error. So I just exited out. I'm still getting my truth table. Everything's working the way I want it to. Again, remember, this is to get you familiar with the software, not necessarily teach you digital. In the digital class, we do stuff like this with the circuits in order to get you familiar with what's going on. I'll ask you at that point to use this software to build the circuit. So I want you to at least have seen it before, put your hands on it, feel a little bit more comfortable with it. And I tidied it up, moved my simulation box up there, save it, and that's it for this week.